Welcome back, everybody. In this video, let's see what AWS Bedrock is doing under the hood. Now, if this won't make sense to you, don't worry about it because in the example, we're going to go through it step by step, okay? So as I mentioned, we have a data source, which is going to be Amazon S3, where we have all our PDFs, all our Word files, and, all the documents of our company. Then we're going to be able to select the splitting strategy, but don't worry if you don't understand that right now. As you can see, the reason we need a splitting strategy is because we want to split the documents into chunks. So, by chunks, I mean like 4 or 5 sentences is perhaps a chunk, okay? So we're going to be saving these documents, like these PDFs files, into these chunks. And once we have the chunks, and a chunk is going to be about like, a paragraph or two, then we create the embeddings for those chunks. And once we have the embeddings, we're going to be using an embedding model, which we have a few options that AWS allows us to choose. And once we have the embeddings, we get back the embeddings from the embedding model, and we save the embeddings in a vector database. Now, if you haven't worked with vector databases before, this is a brief intro, okay? So right now we're going to be using AWS's one of its embedding algorithms, and it's going to be creating for us a 1500 dimensional vector for each word or each token basically. And that means, for example, if you look at this is a vector database. This is a 3-dimensional vector database. Us humans, we can't really understand it past like the 4th dimension. But what you should understand, in machine learning, actually, it's quite common to have these large dimensional spaces, is we're going to be using a 1500 dimensional space where we save all of our data and all our chunks that we talked about, right? So what I want you to understand is, let's say we have created an embedding for the word banana. As you can see, it's going to be close to the word apple, right? Because they're both fruits. So their embeddings are quite similar. And when we look at distances in a vector database, we measure it with a cosine similarity, and that tells us how close these are. Now, for example, over here, you can see that we have the dog, the wolf, the cat, and they're all in close proximity, right? So they're all close together. They're pretty far from, banana and apple. So when you have a query for kitten, it's going to know within the vector database, okay, kitten should be somewhere over here. So it's going to be close to the cat, the dog, the wolf, but as you can see, it's closest to the cat. And so basically, this is the foundation of RAG, or Retrieval Augmented Generation, is that we retrieve information that is relevant to us, okay? So that's the whole purpose of why we use vector databases. So when you ask about like your company's, let's say, how many summer holidays do you get at your company? And let's suppose that HR has uploaded all their documents into this knowledge base. We don't have to scan the entire database. We can just look up what's relevant. And, for example, let's suppose with this case where I ask our knowledge base, hey, knowledge base, how many summer vacation days do I get? And it's going to, perhaps look at these things over here because these might be related to, HR documents, right? So vector databases basically allow us to store similar information close to each other. So when we retrieve information that we want, it's going to be close to the query. So when I ask a query like kitten over here, it's going to know that kitten is over here in the vector database. And so it's going to know that the cats are pretty close to it. The dogs are not far, but a little further. And wolves are, they're animals, but, they're not really related to cats. So that's the whole intuition behind vector databases, okay? So, here we have fruits. Here we have, for example, animals. And over here, we could have our HR documents. Over here, we could have the finance documents. So you can have a variety of different kinds of files basically. So you don't have to have a knowledge base for like only animals or only fruits. They will be stored in the vector database, but they won't interfere with each other because banana and apple are pretty far from the animals over here. So, you can just dump all your files into a vector database and you will see how RAG works. Now, as we talked about it, this is the process. We have our data source, we split it into chunks, we generate the embeddings for those chunks, and then we save it into the vector database. Now, let's look at this other diagram. The user asks, we have the user query, like the user asks, all right, HR, how many summer vacation days do I have for 2024? Now, when we ask the question, it's going to generate an embedding for our question. Okay, so that's very important. And then it's going to retrieve similar documents to our query. So our query or our question actually gets transformed also into that 1500 dimensional space, and it's going to retrieve for us the documents that are relevant and are close by. So it's going to retrieve for us all the HR documents that are related to, perhaps sick days, vacation days, maternity leave, and all those kind of things, okay? Now, once we retrieve these similar documents, we can actually use an LLM, like with Bedrock, we're not going to be using ChatGPT, but we can use Anthropic's Claude model or Cohere's models or Meta's Llama models. And basically, we're going to tell them, okay, here are the relevant information that I was able to find, like let's suppose 500 words or 400 words. Now answer the question for me. And so it's going to look at the documents. Let's suppose when I asked my question about the summer vacation holidays, it retrieved to me 3 different pages of text. Okay, so like a few hundred words. And that's when the LLM comes into play, and it's going to look at all that 300 words, and it's going to tell me which one has the answer. And as you can see, it augments the user query with the retrieved documents, and it's going to respond to me with the correct answer. So this is a kind of a theoretical, high-level understanding of how RAGs work. So in the next video, we're going to get our hands dirty and build one ourselves.